Very good morning. This is Shiv Krishna from DBS Institute of Technology, KAVALI. Today, a presentation on extrusion process. This is unit number 2, extrusion process. What is extrusion? Extrusion is the process by which a block or built of metal is reduced in cross section by forcing it flow through a die orifice under high pressure. In general, extrusion is used to produce cylindrical bars or hollow tubes for the starting stock for drawing rod, cold extrusion or forged product. Most metals are hot extruded due to large amount of forces required in extrusion. In complex shape can be extruded from the more readily extrudable metals such as aluminum. The products obtained are also called extrusion process. The reaction of extrusion built with the container and die results in high compressive stresses, which are effective in reducing cracking of materials during primary breakdown from the ingot. This helps to increase the utilization of extrusion in the working of metals that are difficult to form like stainless steels, nickel based alloy and other high temperature materials. Similar to forging, low ramp force and a fine grained recrystallized structure are possible in hot extrusion. However, better surface finish and higher strength are hardened metals are provided by cold extrusion. Extrusion products. So what is extrusion product? Typical parts produced by extrusion are trim parts used in automotive and construction application, window frame members, railings, aircraft structural parts. Example, aluminum extrusion are used in commercial and domestic buildings for windows and door frame structures systems. Prefabricated houses or building structures, roofing and exterior cladding, curtain walking, shop fronts, etc. Furthermore, extrusions are also used in transport for airframes, rod and rail vehicles, and in the marine application. In extrusion process, so we can discuss it in direct extrusion. The metal built in placed in a container and driven through the die by the ram. The dummy block or pressure plate is placed at the end of the ram in contact with the billet. Friction is at the die and container wall requires high pressure, then indirect extrusion. Indirect extrusion. The hollow ram containing the die is kept stationary and the container with the billet is caused to move. Friction at the die only, no relative movement at the container wall. Requires roughly constant pressure. Hollow ram limits the applied load. Forward extrusion. Metal is forced to flow in the same direction as the punch. Is forward extrusion. The punch closely fits the die cavity to prevent backward flow on the material. Backward extrusion. Metal is forced to flow in the direction opposite to the punch movement. Is backward extrusion. Metal can also be forced to flow into recess in the punch. Cold extrusion. Cold extrusion is the process done at room temperature or slightly elevated temperatures. This process can be used for materials that can withstand the stresses created by extrusion. Materials that are commonly cold extruded includes lead, tin, aluminum, copper, zirconium, titanium, molybdenum, beryllium, vanadium, nibonium, and steel. Examples of products produced by this process are collapsible tube, fire extinguisher cases, shock absorber cylinders, and gear blanks. Advantages: no oxidation takes place, good mechanical properties due to serve cold working as long as the temperatures created are below the recrystallization temperature. Good surface finish with under the lubrications. Hot extrusion. Hot extrusion is the hot working process, which means it is done above the material recrystallization temperature to keep the material from work hardening and to make it easier to push the material through the die. The biggest disadvantage of this process is cost for machinery. Hot extrusion is done at fairly high temperatures, approximately 50 to 75% of the melting point of the metal. The process can be range from 35 to 700 megapascals. Due to the high temperature and pressure and its determinantal effects on the life as well as other components. Good lubrication is necessary. Oil and graphite work at low temperatures, whereas at high temperature, glass powder is used. Types of hot extrusion. In hot extrusion can be divided into three types. First one, lubricated, non-lubricated, hydrostatic. So we can discuss it one by one. Lubricated hot extrusion. Before the billet is inserted into the hot extrusion container, a suitable lubricating system is positioned immediately ahead of the die in order to reduce frictional stresses. Oil and graphite are used at low temperature, whereas at high temperatures, glass powder is used. Copper alloys, titanium alloys, alloy steels, stainless steels, and tool steels are extruded using lubrication. So these are all the lubricated hot extrusion process. Non-lubricated hot extrusion process. No lubrication is used on the billet, container or die for reducing frictional stresses. It has the ability to produce very complex sections with excellent surface finishes and low dimensional tolerances. Solid and hollow dies with flat shear faces are typically used. So we can see the figure also. Next, hydrostatic extrusion. In the hydrostatic extrusion process, the billet is completely surrounded by a pressurized liquid, except where the billet contains the die. where the build contact the die. The rate with which the build moves when pressuring in the direction of the die is does not equal to the ramp speed but is proportional to the displaced hydrostatic medium volume. The process must be carried out in the scaled cylinder to contain the hydrostatic medium pressure, approximately 400 megapascal. Next, advantages and disadvantages of hydrostatic extrusion. Advantage: pressure, which is equal to approximately 400 megapascal. The elimination of large frictional force between the build and the container bar. It's possible to use dies with a very low semi-cone edge angle. Alpha, example, alpha equal to 200. This process can be done hot, warm, or cold. However, the temperature is limited by the stability of the fluid used. Limitations: not suitable for hot working due to pressurized liquid. A practical limit on fluid pressure is around 1.7 GPa currently exists because of the strength of the container. The liquid should not solidify at high pressure. This limits the obtainable applications. Making wires of less ductile material, nuclear reactor, fuel rods. So these are all the advantages and limitations and applications of the hot extrusion process. Drawing. So what is drawing? The concept of drawing involves pulling wire or rod or bar through a die or converging channel to decrease cross-sectional area in increase length. In the majority of the case, the cross-sectional is circular, although non-circular cross-section may be drawn or created by drawing. In a comparison to rolling, drawing offers much better dimensional control, low capital equipment cost, and extension to small cross section. In comparison to extrusion, drawing offers continuous processing, lower equipment cost, and extension of small cross section. The large quantities of wires, rods, tube, and other sections are produced by drawing process, which is basically a cold working process. Drawing is usually performed at room temperature, thus classified a cold working process, but it may be preferred performed at evolved temperatures for large wires to reduce forces. In this process, the material is pulled through a die in order to reduce it to the desired shape and size. In a typical wire drawing operation, once the wire is gripped and pulled to pass through the opening of the die, its diameter reduced to the desired one. Cold drawing properties. Improved size and section, tighter size and section tolerance, dimensional, consistency within each bar, dimensional consistency from bar to bar. Improved surface finish or reduces surface machining. Improved straightness, improved cost effectiveness, production of precision shape to precision tolerances. Increased mechanical properties can reduce the needed for hardening. Yield strength, tensile strength, hardness. Wire drawing. Wire drawing involves stock that can be easily cooled and subjected to subsequential or tandem drawing options or operations, which as maybe dozen or more draws occurring with a given drawing machine. In each drawing operation or pass will involve delivery of the wire to the die from the coil on capstan or drum, passes through the die and take up on a capstan that pulls the wire through the die. Continuous drawing machines consisting of multiple draw dies, typically 4 to 12, separated by accumulating drums. Each drum provides proper force to dry stock through upstream die. Each die provides a small reduction. So desired total reduction is achieved by the series of dies. So in wire drawing, it may be divided into two types. Fine wire drawing, ultra fine wire drawing. Typically refers to round wire with the diameter of less than 0.1 mm. It used in fine wire drawing. In ultra fine wire drawing, it refers to round wires as fine 0.0025 mm in diameter. The annealing before each drawing operation permits large area reduction. Annealing sometimes requires between dies to relieve work hardening. Because of the strain hardening, intermediate annealing between passes may be necessary in gold drawing in order to maintain sufficient ductility to the material and avoid failure. Tungsten carbide dies are used for drawing hard wires and diamond dies in the choice of fine wire. Tube drawing. Tube drawing. Tubes provided by extrusion or other process such as shape rolling. Also, tubes can be reduced in thickness or diameter by tube drawing. The shape of the tubes can be changed by using dies and mandrels with various profiles. The tube drawing is also similar to wire drawing, except that the mandrel of appropriate diameter is required to form the internal hole. Here the arrangements are shown in figure ABC. So figure A with a floating plug. Figure B, fixed plug drawing. Figure C with a moving mandrel. Thank you.